Hello everyone. Welcome to another webinar. First of all, can everyone see us? Can everyone hear us? Please share on the chat if you can see and hear us. If the sound is good, let me know. A thumbs up on the chat. Hello. Hello. So today we have another amazing webinar prepared for you. I'm here with two guests that I'm going to introduce very soon. Awesome. Oh, awesome. People are hearing us. So, first, let me ask you a question. Where are you hearing us from today? Where are you located right now? Let us know in the chat, please. While you answer, let me start. So my name is Andresa. I work on the marketing team at Landing.Jobs, and I just wanna give a quick note on what we do. Landing.Jobs is a candidate-driven tech career marketplace dedicated to matchmaking great tech talent with the best opportunity. We aim to improve the journey of tech professionals from landing a job, learning, and getting paid to deciding where to go and where when it begins. Today, we'll be talking about key concept extraction in data science, an important task for scientific knowledge discovery. And I don't know about you, but I'm very curious to understand about that. And I have here Gloria and Jessica from Springer Nature, and they have prepared a great session for you. But before asking them to introduce themselves, I'd like to give you some technical tips so we can use this tool the best way. So, as you can see, we have a ask a question button on the bottom on the screen here. You can use it to send your questions or just use the chat. We'll be addressing the questions in the end. Please share information about yourself. Don't be shy. Uh, Feel free to ask questions while they are explaining, and we are going to address these questions later. Feel free to engage with each other. This is to be a very engaging webinar. And right now, I'm going to pass the microphone to our guests and ask them to briefly introduce themselves to our audience. Jessica and Gloria, the floor is all yours.
Thanks, Andresa. Well, hello everyone. It's very nice to have all of you here. And I'm Jessica. I'm lead data scientist at Springer Nature. And I'm here with Gloria, also data science at Springer Nature. And we are representing our data science core team. And we intend to walk all of you through the realm of keyword, key concept extraction in data science. And first things first, I would like to say thanks to the Landing.Jobs organizers and for giving us this space to talk about cool stuff, and Springer for allowing us to share some knowledge with the community. And of course, Gloria for joining me. So yeah, go ahead, Gloria, introduce yourself.
Hi, I'm Gloria, as Jessica said. I'm a data scientist also working at Springer Nature in the same group as Jessica. And yeah, that's it.
Cool, thanks. Thanks, Gloria. Well, I think we can start. I'll start with a warm-up perspective from the artificial intelligence field about the keyword extraction task and its importance. And Gloria will give us an overview on how we apply keyword extraction at Springer Nature. We already introduced ourselves, but just a bit more information about our team. Our team has a mission to build AI capabilities, to automate tasks in the publication workflows, and offer better research and publication experience for authors, reviewers, and editors. And well, my background is in computer science. I have a master in machine learning and natural language processing. And now I am applying all this technical knowledge in social data science, more specifically in fairness and bias in AI. Do you want to complement, Gloria?
Yeah, just my background is in particle physics. I have a master's in engineering and physics, But yeah, as past years, I've been working as a data scientist with the current focus being on natural language processing.
Yeah, cool. Thanks. Well, let's start talking about the automatic keyword extraction task. And as you can see, keyword extraction is defined as a task that automatically identifies a set of terms that best describe the subject of a document. And this is basic, but when I say terms, I'm referring not only to words or tokens, but expressions as well. And because of that, we have different flavors of nomenclature, so key phrases, key concepts, segments, or just keywords, right? So much easier. And well, more philosophically speaking, keywords are uh, pieces of text used to break down human language. So we adopt keywords in several situations to summarize or describe a dense piece of text, or to represent a researcher profile, for example, or for top modeling, or to represent your preferences. For instance, when you choose some terms to represent you in a recommendation system, like Netflix or Spotify, these are key concepts that will be used to shape your user experience in that system or life experience, right? Considering the human machine interaction perspective. So even if an automatic method is not adopted, we can usually perform this task intuitively or manually by just analyzing words relevance versus words irrelevance in a document. So it is pretty straightforward for humans, let's say. And theoretically speaking, it is a text mining problem due to the link with the information retrieval subfield. And nowadays is more under the natural language processing umbrella and consequently under the artificial intelligence area. And well, what else? Why do we need keywords, right? So this is the question. So being more pragmatic, we face a lack of keywords to represent documents. And document is any online piece of text, right? Like news, manuscripts, scientific texts, books, journals, etc. So we need automatic methods, to represent these documents. And well, automatic extracted keywords can support users to identify relevant information, right? May serve also to summarize a document and can also be used to improve the performance of search mechanisms like Google search or virtual assistants. And well, can be a feature for clustering tasks as well in order to discover knowledge in, for example, non-supervised machine learning approach. And when talking about approaches, since we are dealing with natural language processing, of course, we can apply simple statistical methods which do not require training data. And when using the statistics of the words from document, like n-grams, word frequency, TF-IDF, and etc., we are adopting methods that are language and domain independent. So this is the advantage of using statistical methods. And besides stats, we also have linguistic methods, mainly relying on linguistic features like part of speech, syntactic structure, semantic analysis, and so on. And well, what else? When talking about machine learning methods, the most used learning style is the supervised one, and where the algorithm learns from annotated data points, And we have the probabilistic ones, for example, naive Bayes or declassifiers and regressors, also support vector machines, C4.5, linear logistic regression, neural networks, and so on. And about other methods, I would highlight text representation like vector space models, or static word embeddings or contextual word embeddings, also graph-based methods, and so on. Yes, we have a bunch of methods to be used in keyword extraction. And well, keyword extraction is done in 2 steps. The first one is the extraction of candidate terms. And these candidates are filtered or ranked in order to get the top X most representative keywords, right? And well, humans are very good at knowing when a number of consecutive tokens should be treated as a unit, but it's not evident, it's not trivial for an automatic indexer, right? So when I say candidate terms, it means when the keyword begins and ends in a running text. And well, in the second step, once the candidate terms are extracted, it is likely that too many terms have been selected, right? And a filtering step is achieved by constructing a model that, based on the values of the defined features, or based on a relevance score, for example, this model can make the distinction of good and bad candidates, you know. And well, last but not least, how keyword extraction have been applied for scientific knowledge discovery. Basically, we need to start thinking about concepts, right? That means noun phrases that describes the main topics of scientific paper, you know. And usually they are extracted from abstracts and ranked based on a relevance score. I will not deep dive here because Gloria is going to illustrate what I'm explaining in theory, you know. And so, yes, this is just a warm up. And yes, Gloria is going to explain and show how we extract key concepts at Springer Nature. Go ahead, Gloria.
Thank you. So first, let me talk a bit more about the group that me and Jessica are part of. So the content acquisition team, it's focused on bettering the peer review process as a whole, and for all those involved. So authors, reviewers, and editors. We have an internal database with their information and publication history, and there's also many teams. Internal teams working on recommendation engines to facilitate this process. So as we have a database. In our database, we create author profiles similar to what you're seeing here from Google Scholar. So this is Nobel laureate Donna Strickland's profile. We can see here her name, the institution where she's working, her email address, and then keywords associated to her profile. For us, the keywords on the profile are an aggregation of the paper level keywords. And these paper level keywords are submitted by the author or the editor to the journal. But what happens, as Jessica mentioned, there's missing keywords. So papers, we have many papers that don't have keywords associated to them. So, and these papers without keywords then lead to incomplete author profiles, which means, so if in an extreme case, if all the author's publications don't have keywords, then the author themselves won't have any keywords associated to them. And you can see this in these example profiles that I'm showing you here. So at the top, we have, again, Donna Strickland's profile. we can see that all the fields are very complete, and there are 10 keywords associated to the profile. And then at the bottom, it's my profile, and we can see that it is very incomplete, and I have no keywords associated to the profile. So this is an extreme case where none of the publications had keywords associated to them. And the solution is then to extract the keywords directly from the papers using natural language processing and machine learning, and then fill out our database so that these keywords represent the expertise of the authors. So what does our data look like? We take, as you can see here, the title, which is highlighted in yellow, and then the abstract, which is highlighted in green. And we pass this information through the machine learning algorithm, and then it returns keywords that are ranked. And these keywords are ranked by the score that the model produces itself. For this purpose of this presentation, I'm going to show you a bit more about the dimensions. And Dimensions is the largest linked research database, and they have a model that's provided via an API that is trained on their data. So this model has a lot of data to be trained on. It's very complete in that aspect. And the model goes through a process similar to what Jessica has explained previous. So given the title and abstract, it goes through candidate selection, then scoring and filtering, and then we'll finally return the keywords and their scores. So as I mentioned, we are looking into author profiles and not just, and we want author level keywords and not just paper level keywords. So we need to aggregate these paper level keywords that the model gives us into author level. I think I confused myself. We need to aggregate the paper level keywords into author level keywords. And we do this based on the frequency of these keywords and the score that the model produces. Yeah, so now it's just going to be a quick demo of the dimensions. You can see it, so we can see it live working with a number of abstracts that we have previously selected.
Well, it's a very simple one in a Jupyter notebook, just to illustrate in an iterative way, let's say. Yeah, we are calling our API in the background. This is just an abstract from one of my papers, and this is the key concepts extracted. And well, considering my research profile, it represents myself very well because yes, I have my expertise in sense representation, language modeling, neural language models, sense embeddings, etc. So yeah, it's very good. And as you can see, we have a key concept with 4 tokens. So it's an expression, it is a term, a real noun phrase. So this is the idea. And we have the scores, the relevance scores as well. Go ahead, Gloria, you can complement.
Yep, it's just if you could put the other
Sure.
abstracts. So just
Yes.
to change the subject, so we know that it's not subject sensitive. Now it would add the abstract of Kate Marie Rosa, a Brazilian physicist, and yep. So this paper in specific, it's talking about inequalities in STEM. And so the output, it's very, if you read the abstract and read the output, it is very representative to what the paper. And then for the next abstract, it is Marta Fajardo, a Portuguese physicist who is it's a laser physicist. So again, the output, it's very specific to the abstract that it's given, and we have, like Jessica pointed out, very long keywords. So for a keyword or key phrase, how you prefer, with 4 different words, showing that the model is able to select these long phrases that, for, as Jessica pointed out, like for us humans, it's intuitive, but we have to teach that to the model.
Yeah, I believe it's important to explain a bit about the relevance score, the score, right? We are using to rank.
Yes. So the relevant score, it's bound from 0 to 1. So a very high relevant score would be the closest to 1, and then the lower score would be close to 0. And we can see here that all these keywords have a relevant score higher than 0.5, but in this case, even 0.6. So they're in the higher section of the score.
Yes, this tool is heavily semantic based, let's say, using large language models in the background and taking advantage of cosine distance. And yes, the semantic similarity score we can obtain by measuring vector distance in vector spaces, right? So this is the nitty-gritty behind the technology. I'm gonna add the last one. This is from a chemist. Go ahead, Gloria.
Yes, Frances Arnold, another Nobel laureate chemist, and her keywords that show up from this paper are, again, very chemistry specific, and we can see that it varies through the different subjects, and it doesn't show any bias in the subject areas.
Yeah, cool. And yes, here we are at the paper level, right? We also have a
Yes, of course.
second step where we aggregate and come up with author level keywords. So yes, paper level keywords are a feature for our aggregator method, let's say. Yeah, that's it. A very simple demo just to illustrate how it works on our side. What else? That's it. Thank you very much for everyone to attend this session. We can open for questions now as well and discussions. I would love to hear some cool questions from all of you.
Thank you, Jessica. Thank you, Gloria. That was really cool. So, people, we are open for questions. If you have any questions, anything you want to ask them, please type on the chat or use the ask question button. I have one that they shared asking if they can have the presentation.
Yes, of course. We
Okay,
can send you
awesome.
the link.
Okay, awesome. So I'm gonna send an email to everyone who sign up with the presentation. And again, you can send the questions on the chat. I'm gonna ask one while people are warming up. So considering people that want to work in data science, what advice would you have for them?
May I start? And maybe Gloria can add some
Yeah, I think you could
thoughts.
start.
Let's see. How can I? Well, we do not have a degree in data science specifically, so you need to choose your background. My background is in computer science, actually, and well, you need to do some master degree, let's say, or PhD, or some extra courses to get an expertise in data science, right? So it's a very new area and field as well. So I would recommend choosing very well your your specialization course, let's say. And well, my degree, my master degree was in machine learning, actually, also in computer science. And my PhD is much more focused on data science right now at Oxford University. So you need to choose, you can choose very well which course and which university, and mainly supervisors as well is important to choose to get your skills in data science and start working on the market.
Yeah, I would just add, nowadays there's a lot of even online courses that can take to like kind of dip your toes into the area. And as I stated, my background is in physics, so it's data related, but not data science related. And so, yeah, those online tools are very helpful to get accustomed to the area, and then maybe an internship or just apply.
Yes, just start with an internship in a cool company like Springer Nature.
Mm-hmm.
And yeah, that's it. Online courses are very useful as well.
Awesome. So while you were answering, you got a lot of questions, which is amazing. So I'm going to ask the first one. How do you handle missing or incomplete data in your analysis?
Well, missing or incomplete data. Usually we have data pipeline. We always try to establish a workflow to handle with the quality, data quality in general, and pre-processing steps and cleaning as well. So this is important before applying any algorithm, any training methodology, right? So this is the foundation of data science in any company. We need to establish some steps, some pipelines to handle with the mainstream of data that we have. At Springer, we use scientific data from papers and manuscripts and so on. So it's a very well structured data, let's say, luck for us. So yes, but in case of missing data, and we always have some methods that we usually apply in data science in general to fix, to improve the quality of this data.
And with the work that the team is developing, what do you think is the impact would what the impact would be in long term for authors and scientists?
Do you want to answer, Gloria?
Yeah. So the goal here is to facilitate the peer review process. And we're doing this now by creating keywords for author profiles. But the general goal is to make it easier for people to publish, for reviewers, and for editors to find their reviewers. So the impact on the science, what was the question? Authors and scientists, the impact on long term would be just to make their lives a bit more hassle-free through this machine learning and all these algorithms that we're creating to facilitate the peer review process.
Yes, and automatize the process. You know, this is the
Yeah.
idea. The process is sometimes manual, using experts for doing it, for reviewing, and so on. And we want to automatize using AI as much as possible to help everyone involved.
So next question, what are some of the ethical considerations and challenge that arise in data science, and how do you address them?
Cool. Ethical considerations. Yes, I am deep diving on it right now in my PhD. And well, mainly we have been dealing a lot with biases present in data, right? So this is a concern we need to have. Well, of course, we have ethical concerns in many levels, but just talking about bias and fairness, for example, this is something we need to consider in our area, for example, since our authors and our papers, manuscripts, come from specific demographic groups, you know, so we need to keep it in mind when dealing or training some model that use demographic information, demographic features, we need to be careful when looking into the country of that author or editor or reviewer, or the gender, for example. All these protected information from mainly from protected groups need to be considered in our pipelines, in our training. So yes, I believe it's a hype to talk about ethics and fairness in AI nowadays in all companies and universities. So yes, hot topic. It's very cool.
Awesome. The next question is whether it's possible to apply the method to a book length text, and for such purpose, what needs to change in the model?
What is the task? A book
A book
length?
length text.
Well, I will assume that considering, I don't know, more uh, dense and huge texts, we would apply some segmentations in our method, let's say, because now we are using only abstracts and titles to extract the keywords. So it is a small piece of text, right? So when considering another scenarios, we need to look into the method for doing it. And as we are using language models, for example, we have specific length in the input of these language models. So this is a limitation that need to be evaluated before extracting the keywords. I don't know, Gloria, do you want to add something?
Um, well, I think you said it well. Like, it would work. Well, the model would work, but I think the what would be extracted probably would be nonsensical, since given the length of the text, and that I don't think this, at least the Dimensions API is set up to for inputs that large. So the segmentation that they do in the candidate selection, I'm not sure how that would work.
Yeah, probably right now the text will be truncated. So yes, we definitely would need to author to change something in the method.
Awesome. And next question is, did you experiment with embedding models, BERT-like, for example, for concept extraction tasks?
Yes, we have benchmarked with some BERT and transformer-based language models, as I said. So yes, some open source models was part of our baselines and options that we have been testing and experimenting with. So yes, mainly the BERT models tailored for trained on scientific tests like SciBERT or BioBERT, for example. So yes, they are interesting baseline and benchmarks for us.
Awesome. That's a good question. How do you keep up with the latest development in data science and machine learning?
What? how how do you do it? What is your secret?
Um, how do I keep up? I mean, I don't. There's
We
too many
try.
things. We
Yeah, we
try.
try. Yeah.
Kind of go by like problem based, and then learn more on that model or technique or whatever, based on the problem that we have in hand that could help create a solution. But in general, there's too much.
Yes, my strategy is to do a very long PhD, so I am, it's mandatory for me reading papers frequently, so I can't escape. So do a PhD in data science.
Those are very good tips. One more question: Are these models available somewhere for us to use? Are there available APIs that can use by general public?
Gloria?
Um, Dimensions is it's not Springer Nature. It's not internal. It can be used by others, but I do believe you have to pay for it.
Yes, yes, just it is Springer Nature, and I believe you can experiment and send some requests to the API. And yes, I add the link in the presentation as well, so you can access the documentation. But yes, Dimensions, it is Springer Nature too. And as I said, we also have other models internally. This is not possible to make available, but the tool we presented today, it is available.
Awesome. One another question: Have you worked with time series data? If yes, what you take using machine learning approach and time series model?
I don't think we have any application using time series because we are heavily working in natural language processing, let's say, discovering knowledge mainly and representing scientific knowledge. So for now, we do not have the need of using some time series data or approach. So, but of course, when considering text generation, for example, this is something that we have been thinking about on generating tests, just using and training generative models. In this case, we can consider some recurrent network, for example, when time series methods. But yes, I do not have anything specific to present to explain in mind right now.
Awesome. And one last question. Uh, how would you describe the working culture at Springer Nature? And what suggestions would you give to people that would like to apply to a job with you?
Let's see. The working culture is very cool, is very meaningful. Let's say is a very good company to work at, and I really enjoy because I have been working my career in startups, but also in huge enterprises as well. But when talking about AI, a company, even a big company like Springer Nature, when talking about AI, doing AI inside, we always try to implement a very open and creative and interesting culture in order to facilitate new ideas and facilitate communication and teamwork as well. Teamwork is very important in our case because we are trying to keep up to date with the area, and we are assuming a huge risk on training models and using data science and AI to solve some real problems, right? So our tools have been deployed in production. We are not doing just experiments and research. We are deploying models to help to facilitate the authors, reviewers, and editors' lives. So yes, because of that, it's important to have a very good culture in our teams and in the company. So I really recommend working with us at Springer. And I don't know, Gloria, do you want to add something?
Yeah, so I agree. I also like working at Springer, and the work that we're doing. It's actually being implemented, and it's rewarding to see that I think these things make a difference, and then in the authors and in the reviewers experience. And also just on a more personal level, coming from the physics background, as I previously said, um, and working as a consultant for a couple of years, coming back to Springer, it's almost like coming back to science. So it kind of like joins both of my interests of being working in data science, but also being adjacent to academia, research, and all of that stuff. So, just on a personal note, that for me really makes me like working at Springer Nature.
Thank you for your answer. So that is a button here on the bottom. If you click, you go to the open jobs of Springer Nature on Landing.Jobs. And I said that was the last question, but you got one that's really good, so I want to do it as well. Have you published a paper on your current study? And can you suggest papers or books on key concept extraction?
Yes, yes. We are researchers as well, right, Gloria? In parallel, it's a parallel life, is another dimension of our lives. And it's common, right, for data scientists. Usually we are doing research as well and publishing papers. So, yes, and people working at Springer usually have papers published with Springer Nature. So, so yes, my main publications are in NLP, natural language processing, and machine learning, and language models and semantic representation, and so on. And yes, of course, we can recommend some papers and books because keyword extraction is a very traditional task in NLP. And we have good books and good papers as well and journals covering all the methodology and techniques, more successful techniques applied in keyword extraction. So yes, send me an email. I can send you something.
Okay, awesome. So I'll send you guys by email later the suggestions. And I want to thank Gloria, thank you, Jessica, for this amazing webinar. And everyone here, be aware we have new events coming up. So keep an eye on our events page. And thank you again. Any final words, any final tips that you want to give?
If you are not working with data science yet, I recommend you just start, and start by doing some online foundational course, let's say. And yes, usually we need data scientists and we need people focusing on machine learning and deep learning as well, and so on. So yes, I really recommend. It's a very cool area, and the applications are endless.
Awesome. So thank you so much, Jessica. Thank you so much, Gloria. Don't forget to check out the jobs at Springer Nature here. And again, I hope to see you on our next events. Bye.
Thank you very much. Bye.
Thank you.
Thanks
Bye.
for attending.